Okay, so we want to use the first derivative test to find the intervals of increase and decrease and local extrema for this function. So let me over here, I'll write down the steps, just a summary of the steps to follow. The first thing that we need to do, as usual, is find the critical points. So we're going to find the derivative, which is 2x minus 4x to the third. Then we set it equal to 0 to solve. And so to solve this equation, we can factor out a 2x, leaving us with 1 minus 2x squared equals to 0. And this is going to give us 3 critical points. So I'm going to make a little critical point bubble here. I have, as a critical point, this one gives me x equals to 0 as a critical point. And then when I set 1 minus 2x squared equals to 0, bring the 1 over, divide by 2, I get x is equal to plus or minus the square root of 1/2. Okay, so that was great. So I found the critical points. And then, remember, the next step is once you have the critical points, then you make a number line. And you test around critical points. Okay, so I have 3 critical points. Let me make my number line. So I have my number line. I'm going to plop down 0, 1 over square root of 2, and then minus 1 over square root of 2. Okay, and so then we pick a point in between. So on right here, left of negative 1 over root 2, let's do, how about negative 4? And over here I can pick positive 4. Now in between here, well, how about, for example, 1/2 would work good, and negative 1/2 would work good. Okay, so, and we're going to test in the derivative. The reason why we're testing those points inside the derivative is because, remember, the derivative tells us whether it's increasing or decreasing, and that's what we're trying to find out. So we're going to plug in negative 4, and then we're going to plug in negative 1/2. And all we care about, we don't really care about the number itself. What we care about is the sign, because all we're looking for is whether it's increasing or decreasing. So I'll plug in negative 4 into the derivative. Now you can plug it into the original one, which you have up here, or the factored one. Usually the factored one is easier to work with, so I'm going to plug negative 4 into that one. So 2 times negative 4 times 1 minus 2 times negative 4 squared. Okay, so everything is being multiplied. Notice that this inside is going to be a negative number, and here we have one more negative number. So this is going to end up being a positive number. I don't even need to calculate what number that is. I just need to know whether it's positive or negative. So since it's positive, that means that the function is increasing on this interval up to negative 1 over root 2. Okay, so then I plug in the next one. I'll plug in negative 1/2, so then I have 2 negative 1/2, 1 minus 2 times negative 1/2 squared. And notice this time negative 1/2 squared, that's 1/4, times 2, that's 1/2. So this time this is going to be positive times a negative, that's going to end up being negative. So that means now that this, on this interval, my function is decreasing. Okay, great. I'm chugging right along here. Now, the next one, plug in 1/2, I would get 2 times 1/2, 1 minus 2 times 1/2 squared. And if you do the same thing, you'll notice this one ends up being positive now, which means it's increasing. Now, don't think that just because in this example it's alternating, that it's always going to alternate. You always have to check, because you don't know. And then last but not least, we plug in 4. 1 minus 2 times 4 squared, and this is going to be negative. So that means that it's going to be decreasing. Okay, and then we do our analysis. Now, we notice that here it's increasing and then it's decreasing, which means that this point, negative 1 over root 2, is going to be a local maximum. Local maximum at x equals to negative 1 over root 2. And here, because it's increasing and then it's decreasing, again we have another local maximum at positive 1 over root 2. So both of those are local maximums. But then now here, notice how it's decreasing and then it's increasing at 0. So that means that that point is going to be a local minimum. So we have a local minimum at x equals to 0. And you're pretty much done. The only warning is that you have this, and this is your x value. You want to also find the y value, because what if your function isn't defined here? Then, it's possible that this could not really be a maximum or a minimum if your function isn't defined. For example, you could have, hypothetically, not in this function, but you could have a vertical asymptote and not even know about it. So you should always find the y value. And you find the y value, remember, by simply plugging back into the original function. So not the derivative, but the original function, which is this one right here, x squared minus x to the 4th. So if I plug negative 1 over root 2, I would get negative 1 over root 2 squared minus negative 1 over root 2 to the 4th is equal to 1/4. And if you do the same thing, this one is going to be exactly the same y value, because they're the same number and they're being squared and raised to the 4th. So, and then here, the local minimum, you would get a y value of 0. So, in summary, you have a local maximum at x equals to negative 1 over root 2, 1/4, and positive 1 over root 2, 1/4. And then you have a local minimum at x equals 0, y equals 0.